We're putting composite objects together. Does everybody remember what a composite object was from grade 9? Yes. Huh? Well, basically, you're just stacking two objects or more on top of each other. So, for instance, the first one, we have a cylinder and a hemisphere, right? So, volume is easy when you stack it because you don't have to worry about things getting covered, essentially. It's just, you know, the two volumes added up. Does that make sense to you? It's the surface area that's a little bit more tricky because what happens when you stack with surface area? Yeah, you end up covering the stuff that you stack on. So when we get to that, we'll address it. But anyways, so hemisphere, the volume of a hemisphere was? My advice to you also is to label it so that it doesn't get all crazy messy. And so these are worth more marks. So then at least if you do one mistake in one of the things, you don't lose multiple marks. So hemisphere volume is equal to 2/3 pi r cubed. So check to see that my 4 is a radius and not a diameter. So then volume equals 2/3 pi times 4 cubed. So we'll punch that in. Okay, we should all be punching this in. 134.04. I know it's saying to the nearest tenth, but I'm going to keep that in there. I don't want you to, I guess I can do that, okay? So that would be a cubic centimeter. So now I'm going to do the cylinder. Cylinder is just like a prism. You take the base area and you stack it, right? So the base area would be the circle, which is pi r squared. And then you stack it by timesing it by the height, right? So volume equals pi times 4 squared times 11. So we'll punch that in. And we get 552.9, and that would be cubic centimeters. And then the total would be those two added up, right? So we get 686.9 cubic centimeters. Okay, check your answers. So now we're going to find the volume of this house-looking thing. So what do we have there? We have a square pyramid, yes? No, that's not even a square pyramid. That's a rectangular pyramid. And on the bottom, we have a rectangular prism, yes? Remember, a pyramid goes up to a point and a prism stacks straight up, right? Okay, so again, for a pyramid, it's 1/3 the base area times the height. So volume is going to be 1/3. The base area is a, does everybody see it's a 15 by 13? Yes? So that's a 15 by 13. That's the area, and then I'm stacking it 12 high. Yes? This should not be rounded, because this should work out nicely. 780. And that would be cubic feet. Okay, and then the rectangular prism is length times width, gives me the base area, and then stack it is the height. Does everybody see that? So it's going to be 15 times 13, and then times it by the height, which is 13. Huh? This dot is times 25, 35, and that's cubic feet. And then we're going to add it up. And we get 3315 cubic feet. All right. And the reason why surface area is harder is because you have to account for all the different sides here, right? So in grade 9, what we did is we found the surface area separately and then subtracted double the overlap. It's up to you if you want to do it that way. Probably the best way to understand this is just find all the different sides, right? And then add it all up. And that's how I probably would recommend. Because there's no, like when they stack, this is actually covering it all. It's only when you have something that's not covering it all, which it doesn't look like they do, that you'd have to kind of account for it. So this is a square bottom. That's nice. Why is that nice? Well, because if it's a square bottom, that means these triangles are all the same, right? Yeah? Okay, so how many sides do we actually have here? Like total? So there's four going around here, right? And there's 4 going around here and then the bottom, right? So it's 5. So my advice to you is to do them all separately, right? So the bottom, and it's up to you how you want to label it, but you have a bottom square if you want, I don't know. Bottom square is 10 by 10, which gives me 100 square centimeters. And then, does everybody see I have 4 rectangles wrapping around there? Yes? So 4 rectangles. So it's going to be 4 times, then it's a 10 by 11. Any questions how I got 4 by 10 by 11? So 440 square centimeters. And then does everybody see I have 4 triangles all the way around? So it's going to be 4 times, now they're nice to you and they gave you the slant height here, right? And the 10 is the whole side, not the 2 ticks there. The reason why they give you the 2 ticks there is so that if you had to use Pythagorean theorem, then you can see that it's a 5 and a 5. For surface area, though, we're using the slant height, right? Okay, so the area of a triangle is base times height divided by 2. So the base is 10, the height is 9, and then that's divided by 2. So it's up to you. You could just say it's 10 times 9 times 2. Does everybody see what I did? So this is the area of the triangle, base times height divided by 2, and then there's 4 of them, right? So 180. Okay, let's check. Do we have 9 sides that we calculated? 4 triangles, 4 rectangles on the bottom square. Okay. So 720 square centimeters. Are we good? Yes? Okay, last one is surface area. Now, you got to watch here because this is a cone, right? And we're not counting the circle, and if you call that the base of the cone, we're not counting that part of it. So you got to watch if you take the formula too literally, you're going to calculate stuff that you don't actually want. So does everybody see? We only need 1 circle area, yes? 1 circle. Then we have the rectangle that's wrapped around that circle, yes? And then we don't need the circle here. We need that lateral surface that's wrapped around. Okay. So now if you look at the formula sheet for cone, does everybody see the formula for a cone is pi r squared plus pi rs? Does everybody understand that the pi r squared, that's that circle that we don't need? But this one is pi rs. Yes? Does that make sense from the formula? Okay, then we have a cylinder, which I don't even, oh yeah, there is a cylinder. So if you see the cylinder surface area, do you see there's 2 pi r squared plus 2 pi rh. So again, we don't need 2 of the circles, we just need the 1 pi r squared, right? And then the 2 pi rh is this part. Now, where do you think the 2 pi rh comes from this rectangle? Do you remember this from grade 9? What's 2 pi r, that formula for? Circumference, and that is this length. From here to here is my circumference. Do you see that? Right? And then from here to here is my height. So does that make sense that it's the circumference times the height? The length is the circumference, and the height is the width of the rectangle? Okay, so that's why I'm saying you're going to have to kind of use some logic of what you actually need here. Okay, so pi r squared, so that's going to be 3 squared. So 9 times pi is 28.3. That's square centimeters. And then it's saying 2 pi rh. So then this is 2 pi times radius, which is 3, times the height, which is 6. That's going to be rounded as well. $113.1. And then the lateral surface of the cone, so that's pi times r, which is 3, times remember S stands for the slant height. Do they give you the slant height here? Or the actual height of the cone? They give you the slant height, so this is just times 5. So then I get 47.1 square centimeters. So then we just add them all up. And somebody check my math there. I get 188.5 square centimeters.